Hello everyone, welcome back. In this lecture, we are going to solve this problem, which is related to the circular lamina. So this is our question: a circular lamina or circular plane of 50 diameter, which is resting on HP on one of its point which is lying on its circumference, and the surface of the circular plane is inclined at 45 degree with HP, and the diameter passing through the resting point. The point on which it is resting, the diameter passing through that point makes 50 degree with VP. So now we are going to draw this projection. So first I'm going to draw a circle with 50 diameter. So our radius will be 25. You can check whether it is of 25 radius or not. So this is 25, radius is 25, so diameter is 50. Now I'm going to divide the circle in half. So I'm going to use construction line for this. Now here. So now our circular profile is divided into two. Now to draw the projection of this thing remember one thing: if you want to draw the projection of a circular profile, we cannot use lines. We are going to use spline fit. This one, we are going to use spline fit for the curve surface, and to accurately track the points to create a circular profile, we need to divide this into multiple we need to divide this circular profile into more than these two parts. So what I'm going to use here is I'm going to use polar array command, in which I'm going to make copies of this circular array, this line in the circular profile. So basically I'm going to divide this thing into 8 equal parts. So just need to do one thing, just like this one. Now activate the array polar command. Array polar. So now you need to provide the center. This is the center about which this is multiple lines are going to be created. So by default we have 6 parts. From here you can go to this items, and instead of 6 you can type here 8. So now our circular profile is divided into 8 equal parts. Okay, now you can name these parts. This one is okay. Change it to main right now. While it is resting on the HP on one of its point. Suppose this circular profile is resting on this point A, which is, as per the question, lying on its circumference. So now this is the top view. So from this top view we are going to draw our front view. From the front we will get a line. Extreme points will be this one and this one, and this point again will lie, these 2 points D and H will lie on the same point again. Here G and C will be on the same line again. D and F will appear on the same line. So our top view will start from this point, here to here, here to here, and here to here. There's a reason why I'm making this front view in multiple segments. It will appear later why this thing is done here. Just going to change this to main drawing. Now you can name them. This one is going to be, this point represent A dash, and this is going to be B and H, dash M, B dash, this will be C dash M, C dash, this is going to be F dash M, D dash, this is going to be B dash. Okay, now just need to change this to the main drawing. So this is our first part. Now it is this lamina is resting on HP on one of its corner. The resting corner is A. So while resting on HP, front view will be a straight line. Now, as per the second question, while resting on A, this profile making a angle of 45 degree with HP, inclined at 45 degree to HP. Okay. Next step to create the front view. Okay, now for the next step, I'm going to select this. Just make a copy from here to here. Now this thing or this surface makes an angle of 45 degree with the HP. So in front view we will have a inclined line. So just rotate this thing about this point. Why this point? Because it is resting on A. So that is why it should stay on the reference line. And the surface makes 45 degree with the HP. So just check this thing. Now this line is inclined at 45 degree with HP. So now from this front view, when this surface get inclined at a 45 degree with HP, so in front view we will have the inclined line. Now from this inclined line we have to trace out our top view. So okay, previously I told you I've created this front view in multiple segments. This one segment 1, 2, 3, 4. This is done because if I've created a single line from here to here, so it is going to be very difficult to trace out that S dash B dash point with an accuracy, with an accurate length. That is why I've created this front view in multiple segments. This is from A dash to B dash S dash. So this is our first segment. So it is easy to trace out the line, this point from here. That is why I've created the front view in multiple segments. So first I'm going to trace out this point A dash. So this is a A dash line. Now from here, this is a A dash horizontal line. Now just create this thing up to this point. This is point of intersection. So you can just copy this thing here. This is our point A, and from here you can see this is our point where B dash, which is represented by B dash S dash. So just create a vertical line, because on this vertical line we have both the points B and H. So just create from H a horizontal line which will intersect with this line. Now again follow the same thing for this point B. So this is going to be, this intersection is going to be B, and this one is H. Now our next step is we need to trace out this G and C. So both these points lie on this vertical line. This is point C. And this is our point G. Just copy these things, these notations. This is point G and this is going to be C. Now again next step is to trace out this one, this segment F dash D dash. So from here, this one. Now from F1, the same line from here to here, and this one be here. So this is going to be F, and this is going to be D. From here to here. So this is our point E. Now to create the circular profile, we need to use the spline fit command. Okay, leftmost, this first command, spline fit. just click here. Okay, need to change to the main drawing. Select the main drawing layer. Now select this spline fit, point A. Now this is B, C. This is the last point. Now before completing this thing, just stretch your mouse a little bit further so that we can get a continuous profile here. If I close this thing here, so we will not have a continuous circular profile. So I'm just going to stretch it like this and just right click, enter. So this is a circular profile, or very kind of circular, using the spline fit command. So now I need the inside one, these points. So I'm going to just remove this outside construction line. And for the third step, it is given that after rotation with HP, this thing, the diagonal passing through the resting corner. This is a resting corner. So this is our diagonal which is passing through the resting corner. AE is the diagonal, which has been asked in the question. In the question, it is given that the diameter passing through the resting point. This is the diameter, this AE, which is passing through the resting point, and it is making 50 degree with VP. So now we have to rotate it in such a way so that this AE diagonal inclined at 50 degree with the VP. Just going to copy this thing here to here. Now just select this thing and rotate it about this point. I'm going to rotate it about this point, just 50 degree. Now you can check whether this diagonal is inclined at 50 degree or not. This one is 50 degree. Okay, so our question is correct. Just move this thing a little bit in downward direction. Okay, just now we need, this is our top view in which our AE diagonal, which is passing through the resting corner A, makes an angle of 50 degree with the HP. So we need to just trace out the front view from the top view. Just going to select this. So I'm going to trace out first point A. This is A, which is on the reference line. Now point H again, which is on this line. So I'm going to, from here, this is the horizontal line in which we have 2 points H and B. So this one here is H, so this is H dash, and this one here is B. So now just select this and create a vertical line going to intersect with this line. So this is our B dash. So just mark this B. Now remove this thing. Now what we have here is G and C. Both these points are on this horizontal line. So just select G here. So this intersection is G dash, and this is going to be C dash. Just copy these things, G and C. Now we need to select, we need to trace this F and D. So this is our point F, this is going to be F dash, and this is D. So this is our, so this one is F dash and this one is D dash. Now we need to identify E dash. This is the horizontal line, and this is our top view. So this point is our E dash. Now again you have to connect this line with the help of main drawing. So just select, again we have to use this spline fit. Now connect these points. This one is A dash. So just copy this thing. Initially, we have find out a point which is A dash. This one here and this one here. So just need to connect these points. A dash, B, C, D, E, F, G, G. This one is this one here. We have H. H is here. Okay, so this one is G, and this one here. This one is H, and this line is for H. So this is a H. Now just touch this thing a little bit and click enter. So this is our profile. So this is our solution in which you can see I'm just moving this construction line so I can just clearly visualize this thing. What we can say is here from okay, we need this diagonal here. Just connect these two lines from this is A and this is E. This is the diagonal which should be at 50 degree. Okay, now from here what we can do is you can see here this is a rectangle circular profile which is resting on a point A which is on its circumference as it is asked in the question, and while resting on this point, when resting on this point A on HP, the front view is a straight line. Now while resting on A, the circular surface makes an angle of 45 degree with HP. So in front view, we will get an inclined line, which is at 45 degree with HP. Now, so in top view, we will get a compressed circle. So if you incline the surface with HP, so it will get compressed diameter wise in the horizontal axis. So this is our top view after the rotation with HP. Now, it is asked in the question after this thing the diagonal which is passing through the resting point, this is a resting point, the diagonal passing through resting point is this one AE. So this thing is supposed to make an angle of 50 degree with the VP. So here AE makes an angle of 50 degree. So this is our top view, and from this top view we have traced out the front view. So this is solution to our circular profile question. That's it. Thank you.